In physics, free body diagrams are also known as dot diagrams. They show the forces and how the forces interact. Forces are due to something specific. There is a force due to motion. It is either a push or a pull. It is applied. Okay, so force due to motion is a force applied. Okay, you also have a force due to gravity. So force due to motion, force due to gravity, and that will always be downward because gravity is pulling us down, and it is an Fg. Then you have forces due to air resistance, forces due to friction, both of these are a resistance. They are acting opposite the direction of motion. And it is, both of them are basically a force due to friction. Okay, so that is an F with a little f, or I have even seen it as for air being force due to air. Okay, either one will work if you're dealing with air resistance. For friction alone, it's the capital F, lowercase f. Then you have a force due to tension. Tension is caused by ropes, string, cable, wires, rods. And this is a force T, force due to tension. Then the last one is a normal force. Normal force is when something's touching, it is perpendicular, to the surface, okay? So that means it makes a 90-degree angle with the surface always. And it is upwards or pushing out. And force normal is an F, capital N. For example, let's say we have a car stopped on a hill. Okay, so what does that look like? Here's our hill. Here's our car. We have two forces involved. We have the force due to gravity acting straight downward. And we have the normal force, which is perpendicular to the surface. That is a dot diagram for a car stopped on a hill. Now, what if we have a book on a table and the book is being slid to the right? So we know it's got a motion this way. It is being accelerated something. We know there's a normal force and a force due to gravity. We know it's moving to the right, so we have to have some force that's being applied. Okay? And we have friction. So friction goes back this way. This shows us that it's moving to the right because our force applied arrow, our vector, is longer than our friction vector. It's not moving up or down because our force normal vector is about the same as the force due to gravity vector. Now what if we have air resistance also? That means we'd add another arrow, and that would be force due to the air resistance. So is now the book accelerating? Yes, because if you look at the arrows, our friction and our air resistance, they add up, but it's still a smaller number than the applied. Now, if you look at this free body diagram, we know we have a force applied that's 10. We know we have a force of friction, that is 7 newtons. We know our normal force is 5 newtons, and our force due to gravity is 9 newtons. So what's going on? Well, we know the motion to the right is greater because you have 10 minus 7. So we know it's moving to the right at some roughly 3. And we know it's moving down because 9 is greater than 5. So it's moving down. Let's make it a little bit bigger than our 3 at 4 newtons. So the direction this object takes in reality would be something like that. So it is moving in this direction. Okay, now we have this problem, and we're wanting to know the force normal. Well, it's moving in a straight surface, so the force normal is going to be equal to the gravity. So force normal in this case is going to be 2,500 or 2,500 newtons. Now what if we're wanting to find out mass? Well, what is mass? We know force is equal to mass times acceleration. We know acceleration due to gravity is 10 meters per second squared. So we have 2,500 equals some mass times 10. So our mass is going to equal 2,500 divided by 10. So our mass is 250 kilograms. So now, let's see what else can we find about this problem. We know it's moving to the right. Well, how fast? Well, we subtract, so we know the force of acceleration has to equal the 7,500 minus 500. So it has to equal 7,000 newtons. Well, what is our acceleration? We know mass, we know our force, we know our formula. So we have 7,000 equals mass of 250 times our acceleration. So let's rewrite that so it makes a little more sense. We have 7,000 equals 250 times our acceleration. So our acceleration has to equal 7,000 divided by 250, which is 28 meters per second squared. So that's how you solve those problems.